Hi, my name is Steve Loughlin. I'm from Hortonworks, and I'm here to talk along with Nirmal about Hadoop on the cloud. As Kim said, I work at Hortonworks. I'm actually a long-standing committer. My main hobby is breaking bits of it, and most recently I've been working on this Openstack stuff. So I'm here to talk a bit about what we've been doing with Rackspace and others on getting Hadoop and Openstack to be friends. So the key topics, I'm going to be talking about the key drivers for Hadoop in general. Then we're going to look at how Hadoop fits in with Openstack. Then over to Rackspace, who are actually going to be showing this stuff at work. So why Hadoop? I hope a lot of people on the call already know what Hadoop is, understand what it can do. But for everybody who doesn't know yet, the key point is that Hadoop is becoming a focus for kind of the next generation of applications where we're being very data-centric. And we're doing that because there is lots of data that we can collect. And we've shown the proof of concept applications and the web companies are showing that they can make tangible return investments on doing this, either in better business decisions or in building applications around it. And as a result, Hadoop is almost becoming another part of modern back-end applications, the way web servers have become, the way transactional databases have become. Now you have to have Hadoop somewhere in there. And the ultimate driver for this, the source of all this change, is data. We've often had data we've been collecting before, like server logs, like click logs, like purchase records. But there's been so much of it, it's been too expensive to stick in things like classic databases. So you've maybe summarized it and then discarded it. Now that the cost of storage on platforms like Hadoop is so low that we can afford to keep it, then you can keep it rather than know in advance what analysis you're going to do. You can start keeping historical data. You can go back on it years later and reanalyze it and reinterpret it. That's today's data. The other big change is the more and more devices connected to the internet, that's everything from cars to phones, the more and more sources of data we have. Everyone carrying a mobile phone running your application is providing an intermittent stream of data on what they're doing, where they are. And privacy legislation notwithstanding, that is a really interesting way to analyze what people are up to for whatever kind of organization you are. Those same devices, they're collecting data that is unstructured, that's text, that can be fed either directly to you or something like the Twitter Firehose that's being shared with everyone. They can be picking up photographs, and it's all data that is too unstructured, semi-structured to be processed in classic databases either. So it's that different formats and types of data mean that existing application architectures don't work either. So new types of data, you can do new applications built around it, driven by actual business need. It's not enough to do it because it's interesting, it's got to be tangibly useful. And that's you've got to identify that before you start going on, I think is a key point. But once you've done that, you've got to think, okay, we've got Hadoop. How are we going to actually integrate with our organization? The web companies, they started off with the clean sheet and said, we are going to not integrate this in our existing stuff. We're going to start from scratch and rebuild everything. And they did that because they had to fend for themselves. If you look, people like Google and that, they build their own Linux kernels, they build the stuff on top, and just maintaining and writing the application on top is just part of the work they've had to do. But that was done because they were first. They didn't have a choice in the matter. Now we do have a choice. And in the enterprise, unless you actually want to do it yourself, you can opt out of doing it and generally say, I want something that is bundled, supported, that integrates with the rest of my world. And what that means from an enterprise perspective in terms of product is something that has the storage, the data protection, and security requirements that your existing IT team suspects. It's got the management tooling, and it's actually got the application layer, the API that people working with Hadoop come to expect. So that's something to do with HDP, Hortonworks Data Platform. And I think the point about this is it's got to run on the infrastructure that your IT team agrees that is relevant to it. So depending on how you are deploying applications right now, you've got to think how Hadoop fits in this world. Is it going to be racks for bare metal? Is it going to be virtualization on your premises, or is it going to be the external cloud infrastructure? And today we're going to be looking at cloud infrastructure. So that's the hardware. The other thing about is if you're looking at adopting Hadoop in your enterprise, you can't run out and buy a new set of engineers. You've got an engineering team there. They understand your organization. They understand it better than anybody else. They've got their own excellent programming skills. So what we have to do is think about how do we shape Hadoop in a way that works with your existing people. So the developers, no matter what programming language and tools they use, they need to be able to work with Hadoop, which is why there's been work on .NET integration, why Spring are working on, I've got something called Spring for Apache Hadoop. Your ops teams, they need to be able to work with it from the management tooling. And anyone actually doing analysis, trying to understand this data in terms of ad hoc queries and that, they need to be able to work with it too using their tooling, which is either SQL queries, integration with statistics platforms like R, and interesting enough actually Excel, which, while it's not so regarded as an analytics tool, is actually a very widely used one, and Excel 2013 will actually work directly with Hadoop, which is useful to know. So skills, there's hardware, and finally, it's got to integrate existing applications. If we're saying Hadoop is actually the place to support the new data sources, the sensors, the sentiment analysis, the unstructured, you don't want to throw away the old applications. If you've got things that work, then stick with them. What you want to do is use Hadoop as an adjunct to your existing code base, which you want to leave alone while it's working. So in here, we've got an architecture where Hadoop lives alongside it. It's an extension of what you've been doing originally. It hooks in together with things like your databases in the enterprise warehouse. And it can extend those applications you've got. It can add extra features to it. It can add stuff on the side. And you can start thinking about writing your applications that both use things like Hadoop and transactional databases. But you don't want to throw away everything you've got just because there's a new toy around. And that's key. Hadoop is a tool, and you've got to find its place in the world. One place is the physical world, where you've got a set of machines dedicated to it. Again, the web companies do that because they know about the scale, and they're driven by the cost of storage. But it does come at the price of flexibility. You've got to dedicate those machines to Hadoop. With the stuff we've been doing with Openstack, we've been working with the Openstack people, where the focus is, can you do more agile work? Can you have agile clusters where you only have them for short periods of time? You can scale them up and down based on your load. So you can write applications which adapt to demand. And you can do that in a lot of virtual infrastructure. You can run Hadoop on different types of VMs for a long time. But what we've been doing, Hortonworks, with work with Rackspace and other OpenStack people, is focusing on getting Hadoop to work better with OpenStack, taking advantage of the fact that we're both open source projects. So we've actually been making changes into each other's code to integrate with each other. So now Hadoop and OpenStack, they're aware of each other, and they work better together than anything else, really. A key bit of the work that I was busy with NIM on for a long time this year, was a new Swift, connecting up the OpenStack Swift object store with Hadoop. As anybody that's used OpenStack will know, the object store, Swift, is where you keep long-lived data. When you bring up a virtual machine, you've got a hard disk there, but when that machine goes away, all the data on that virtual disk goes to, and actually make a snapshot of it, but that doesn't scale out very well. So Swift, the object store, is where you keep your data between VMs. So for Hadoop to work in an OpenStack environment, it is absolutely critical that you can work with it. And that's where this Swift file system driver comes in. Normally in Hadoop today, you talk to a file using a URL. You run an application like a MapReduce job, like some other analysis, and saying, here is the URL to a directory containing all my data, and Hadoop works with it using whatever queries you've got. What we've done with this Swift file system is we give a different URL. You have a Swift prefix to it, and you can refer to a Swift container after that, or basically a Swift container from a specific Swift object store. And you can use that as the source or destination of your data now. And you can hand it in to any bit of Hadoop code that normally takes an HDFS URL as a source of data, you can just say, right, read it from this Swift object store. And again, the output, you can say, oh, put it back into Swift. What's interesting here is it's not just, this is absolutely essential to work when you're using Hadoop in Openstack, because it's the kind of the local storage for your cluster, persistent storage. But actually, you can also use it to access remote data too, on any Swift object store you can get over the network. And that means you can think of applications where you are running Swift, you're running Hadoop on one Openstack cluster, but you can talk over the network to others. And in fact, that's roughly how we did our development as well. The Rackspace team, they were running Hadoop in their clusters, talking Swift locally. I was developing from my office remotely, and I was talking Swift to their data centers in the US and the UK, just from my little local Hadoop cluster and from my desktop, because the Hadoop code doesn't really care where your data is in Swift, as long as it's reachable over the network. So this is the key point. This file system lets Hadoop code talk to, read from and write to a Swift file system, which means that you can now run Hadoop inside Openstack working with persistent data. We still have the Hadoop file system, but it only lasts as long as the cluster. Which leads to an application architecture like you can see on screen now. On the left, we have the persistent Swift service, which is collected from a pool of machines, each with persistent hard disks, and they store your data forever. You save a file in there, and Swift keeps multiple copies of it, so if any server fails, it's got backup copies. And that's the object store. When you actually create a cluster, using the tools you'll be seeing in a minute, you create a set of VMs in the OpenStack cluster, each of which are running Hadoop, and they have a virtual hard disk which they can use for storage as well, Hadoop storage. So these VMs, they do bring up between them a copy of the Hadoop file system, HDFS, which is where we normally store data in a physical cluster. And the way HDFS works, if you don't know about it, is it takes data, it takes a file, and it breaks it up into blocks. So you can take say a 500 megabyte file, it can get broken up into blocks of 64 megabytes. These blocks are then scattered around the set of machines, so only one machine has one copy of the block. And then into the replicas. So if any machine fails, there's other copies of that data there. But by scattering it across different blocks, by scattering blocks across different machines, we can have more machines can access that data locally, because Hadoop is biased towards saying we're going to give performance by accessing data locally rather than over the network. So once it's in blocks, you can access it in parallel. You've got very fast reads. When you write, it gets written back in blocks, and then the Hadoop file system nodes talk to each other to keep those replicas up to date. So HDFS, it's a very fast file system for Hadoop analysis operations for reading data, but in a virtual world, it only lasts as long as your cluster. As soon as you press the button on the web UI, when you take that cluster away, all those VMs are going to go away along with all the data in them. So that Swift is where you keep data that you care about. So once you start using Hadoop in the Rackspace Cloud, what you're going to have to think about is designing an application so that Swift is where data gets collected. When your application is switched off, when you don't have a Hadoop cluster, you can still stream data in there. For example, you could have web servers running on different VMs. They can be pushing their logs out there, their purchase logs, their server logs, into Swift containers. Then, when you want to analyze it, you can start a Hadoop cluster of the size of your trees. Bring that up, have it read in all the data, do its analysis. If you've got a chained operation, storing your data inside HDFS is the way to get maximum performance, to get the fastest answers. But you run through it locally, and then once you're finished, you have to push all the data you actually want, your answers, back into Swift so that you can make use of them later. So Swift is the glue that binds together applications in OpenStack. That's key architecture here. You've got to think about that, design it, Swift for persistence. Hadoop clusters come and go based on demand. They scale up very nicely on demand too, but you can't keep data in them. Not unless you're going to keep the cluster up all the time. So that is the core architecture, Swift and HDFS. And now I'm going to hand it over to Nirmal in Rackspace, who's actually going to show it working. So Nirmal, are you online?
Yeah, thank you, Steve. Hi all, I'm Nirmal Ranganathan from Rackspace, and I primarily work on building out our Cloud Big Data Platform, which is a scalable Hadoop service built on top of Openstack and the Hortonworks Data Platform. So I'm going to actually quickly run through a demo of creating a cluster and running a simple pig job and actually expanding on what Steve spoke about. So it's going to pull data from Swift, process the data, and push the results back into Swift. So we have a UI that allows you to easily create clusters. I'm going to go ahead and click Create Cluster. It's as simple as these 3 steps. All you need to do is provide a cluster name, choose what region. So right now we just offer the Dallas region. Choose what cluster type. Currently we offer HTTP 1.1 and 1.3. I'm going to choose 1.3 here and choose what node sizes you want. I'm just going to choose the smallest one for demo purposes. And the number of nodes, let's say 5 nodes. So when you create a cluster with Rackspace's Cloud Big Data Platform, you choose the number of data nodes. Along with that, you get a name node and you get a gateway node. So let's go ahead and kick that off. So that'll go start building out the cluster and all the nodes. I'm going to switch back and actually go ahead and run a pig job. So I'm just going to use the command line to do some of the remaining operations. So that's just listing the clusters I have. I'm just going to use the demo cluster to go run the job. The webinar cluster is the one that we just built, and it's building. So the command line tool offers a few nice features to actually access the cluster, do some operations on the cluster. So for example, the Lava SSH demo gets you directly logged onto the gateway node. The gateway node is a jump box from where you can run your scripts or run your jobs and install other libraries that you want to have. So I'm just going to kick off a pig job. So before I start that, so this is a very simple pig job that's actually pulling data from Swift. So if you look at it, it has a Swift URL. Wikipedia is the container name. RackDFW is the region, and then whatever file name. So that file actually exists on Swift. So it's in the Wikipedia container, and that's the file. So it's a small file, but for demo purposes, we're just going to run through that. And it does some processing and outputs the results back into Swift. So it's going to put it into a container called Strata, same region, under a folder called results. So I don't have a container called Strata. Let me go ahead and create one. And choose the same region. So right now it's empty. Once the job completes, the results will be here in this container. That'll go ahead and kick off the pig job. While that's happening, let me show you a few other things. So to access the web pages, so name node and the job tracker web pages, it's all firewalled off. So to access it, you got a proxy and to the gateway node and access it. So I'm going to do this. So Lava SSH proxy actually creates a proxy for me. I'm going to say proxy to port 4000, and that's the cluster I want to access. Let's create a proxy. I have Firefox configured to use that proxy. That lists all the data nodes and the name nodes. So this brings up your familiar naming of web pages and job tracker pages. So these are running on the internal IP. That's just internal to the data center, and that's the external publicly accessible IP. But no one will be able to access it. You need to be able to SSH proxy into it to be able to get to it. So I'm just going to kill that proxy. Trying to refresh that, just want to load it. So while the job's running, let's talk about some of the use cases. Where Hadoop is ideal in the cloud. So to start off, what are the advantages of using the cloud? So, I mean, most of you already know this, but it's very fast to provision clusters or servers. It takes a few minutes, and you have a running cluster or running servers ready to go. You don't need any manual configuration. Everything is done for you. All you have to do is set up your application or set up your workload and run your jobs. That's the easy part of it. And it's very flexible. You can scale up, scale down anytime you want, and it's all at the click of a button. So it makes things easier for you to get started and work your way up. Let's see what are some of the use cases that apply to Hadoop. So primary cases where it really helps in Hadoop deployments is for development environment of Spark clusters. So with the development environment, you want to run some sample queries, you want to test out a job, test out a MapReduce job or a big job, big query, and you don't have access to resources, so you can just spin up a small 2-node cluster, test your job on some sample data, make sure your job works, and then actually deploy it on a production environment. So you can easily spin up a development environment and shut it down. So fast turnaround. The other part is a Spark cluster. So with Spark clusters, you really don't know what you want. You're trying to experiment with things and see what fits and works for you. So this way, so you can evaluate Hadoop without any commitment, and there's no contracts, right? You can spin up a cluster, work on stuff, and then maybe delete in a few days once the cluster's ready. This also helps you when you have a Hadoop environment, you messed up something, and you just want to start with a clean state. Just go ahead and delete your cluster, spin up a new one in a few minutes. Another good advantage with this is it gives you the full HTTP installation, so you can test out a full Hortonworks distro without having to actually set up physical gear. Another use case is dynamic clusters, and I see a lot of customers wanting to do this, right? You don't want to have your Hadoop cluster on all the time. You just want to run, say, a nightly job or a weekly job, in which case you spin up your cluster at the end of the day or at the end of the week, run your jobs, and then you shut the cluster down. As Steve pointed out earlier, you can create your applications or workloads around combining Swift and the Cloud Hadoop product. That way your data can reside on Swift. You can pull in your data, run your job, push your results back into Swift, and get rid of your cluster. That way you're not paying for unused cluster time. Another good use case, which pretty much everybody in the Hadoop world runs into, you don't start with 100 terabytes of data. You probably start with 100 gigabytes of data, probably a terabyte of data. And you grow slowly or exponentially. And that's where the cloud really stands. You can start small, start with, say, a 5-node or a 10-node cluster, maybe 10 terabytes of disk space. And then as your needs grow, you can expand into, say, 100 terabytes or a petabyte, all painlessly and effortlessly with just push a button. And the recent trend is everybody is starting to run the applications in the cloud. And some of the examples that Steve pointed out earlier were clickstream data and processing log files. The applications that collect all the clickstream data and application logs are already in the cloud. All you have to do is just push that data over to Swift cloud files. You have data stored for retrieval anytime, and then spin up a Hadoop cluster, run your jobs, pull that data in. That's where the connector is really helpful. That way you don't have to have a live HDFS available for you all the time. You can just put story data on Swift and pull it for whenever you need it. And this just necessarily doesn't apply just to Hadoop, right? If you want to do anything else with that data, you still have the data on Swift, and all applications in the cloud still have access to it. So I want to talk a little bit more about our offering. So right now, we provide Hortonworks Data Platform 1.1 and 1.3. We're going to soon come up with the 2.0 version of HTTP, and we're also going to be providing HBase. So right now with the 1.1 and 1.3, you also get big Hive and H catalog, so you can run big queries and Hive queries. That's all set up and configured for you, ready to go. And some of the big pluses of the platform are it's secure by default, so it's all firewalled off. The cluster is just accessible by you, and all the nodes are configured with IP tables so that the required ports are open for the required nodes. And as you scale, we open up the required ports so that only your cluster has access to all the data. So it comes pre-optimized. So depending on the flavor type you choose, the Hadoop configuration is optimized for that flavor sizes, with respect to memory and processors. So the number of mappers and reducers and all of the configurations that come with it are automatically set for you. So all you have to do is go ahead and run your job. So I already demoed the web UI. So we have a web UI. We have a command line client that I was running on earlier. And then we also have a REST API. So both of the web UI and the CLI are backed by the REST API. And all of this is on local disk, and it's all 10G network. So it gives you a highly performant Hadoop cluster on the cloud. So Openstack. So this is a product that's built on top of two huge open source projects in their own realm. Openstack is by far the largest open source project when it comes to a cloud operating system, and Hadoop by far is the largest or the biggest project when it comes to anything to do with big data. So that's why it makes real sense to actually combine these two and have a product offering built on top of it. So I'm just going to talk a little about Openstack and what are the components that comprise of Openstack that are utilized for the product. So there's a couple of shared services. So authentication and image storage. So those are shared services that are utilized by the platform. Compute is Nova, which is the project or product that provides the virtual servers. A networking component is built in to provide all the networking requirements. There's also going to be an option to be able to do private networking, so your cloud servers or your cluster nodes are on a dedicated private network. And storage has two components. One is the block storage, which is called Cinder, and object storage, which we've been talking about all along, is Swift. And for this product, so right now we're using compute, networking, and Swift for the object storage. And then the dashboard is the Reach UI that you just saw earlier. So our application, our platform is built on top of this foundation and also on top of the Hortonworks Data Platform. Why does an open platform matter? So everything here is open. The Openstack pieces are open, available to you. The Hortonworks pieces are open, 100% Apache, Hadoop source. So everything is available. There's no lock-in. Why this really matters is it facilitates an easy adoption lifecycle where you can start small. As you can see, you can start with just the sandbox. You're playing with Hadoop for the first time. Work with the sandbox either in your local VM or on the cloud. See if Hadoop is the right fit for you. Work with some of the Hadoop applications and test it out for yourself. Once you're ready, once you think you want to move on, the first thing you're going to start doing is probably creating a proof of concept or creating a development environment. And the best place to do that is the Cloud Big Data Platform, where you don't have any commitments, no contracts. just spin up what you need and then tear it down when you don't need it. So the flexibility of working with Hortonworks is it's a standard platform and it's available across multiple environments. So you can have it in your public cloud environment. You can run the same Hortonworks distro without any changes on a Rackspace managed platform, which is on bare metal. Or if you want to just run on-premise, then you can run it on-premise on your own Rackspace Private Cloud Edition. So this way you have the flexibility to choose between how you want or where you want to run your cluster as it suits your need. So overall, when it comes to an open platform, you have a choice. You can choose to either go closed source and not be able to port your data or port your applications, or you can choose the open platform and it's your call. Whenever you want to move, you're ready to move. Everything is available freely. You can just go deploy it wherever you want. So that's, I think, the biggest plus in having an open platform. So let's go look back and see if the job completed. So that's the big job we ran. And it's completed successfully. So if you look here, it's written 300,000 records back into Swift. So it's dropped the results back into the Strata container. So this was the one that was empty earlier. Let's refresh it, and the objects or the result files should be in there. So those are the result files. So this is just a simple demo. What I did here was just pull off some metadata from Wikipedia about places that's there on Wikipedia. This is only a sample subset. And I then went ahead and processed them using a big job, and then dumped them into Google Fusion tables and plotted them on Google Maps. This just gives you a link to stuff. So it's not much, but I mean, there's a whole lot of things you can do with this. That's just a start. So I just want to show you one more thing before we move on. So I showed you a few commands earlier. So there's also the option of actually gradually transferring data into HDFS, so you can SCP files directly into HDFS. Let's go ahead and SCP the results file. So there's two things I can do. So I can SCP the file normally to just the local file system. So I'm just going to SCP that to demo cluster. What that does is that SCP the file over to your local file system. I'll go and show that in a little while. And you also have the option of SCPing the file directly to HDFS. What the second one does was it actually copies the data over to HDFS. So, oh, I guess it copied this. So you have the file over here on the local file system, and the file is also available on HDFS. So that's one thing I want to show before I finish off. So I think with that, I want to wrap up and thank you all. Kim, do you want to take over?
Yeah, that's great. Thank you so much for sharing the demo with us. Like Nirmal was saying, this is kind of just an introductory to what you guys can do with Hadoop and Hadoop with the cloud. Over the next couple of weeks and months, we'll probably get some more use cases for you guys to try it out, especially with the sandbox being a trial for you within the Apache, within the open cloud. So a couple of things that we kind of want to use as a call to action. If you want more information about the Rackspace Cloud Big Data Platform, there's a website on there. Access it, log in, and get more details around it. I know that you can actually contact Rackspace if you want to have experience and try out this particular offering. The second step is trial our sandbox. It's on our website right now. It's the 2.0 version of the sandbox. Within the sandbox, so for those of you who haven't seen or experienced a sandbox, it's a virtual machine that you can download on your laptop and play around with our full Hadoop distribution in a one-node cluster. So within the sandbox itself, there's about 16 tutorials that kind of take you through the experience of learning Hadoop, and then you can also play and connect it with different partners that we have tutorials for, like Tableau, MicroStrategy, any BI application that you want to connect to the sandbox. And the third thing is, with the partnership coming up, we're going to be doing a lot of tweetings on use cases and blogging about things that you can do with Rackspace. So do follow us on Twitter at Hortonworks and at Rackspace to kind of keep yourself informed, and and just can kind of have a conversation online. So please do that if you haven't done that yet. So with that, I'm gonna look through the questions you guys have. There's lots of really good questions, so thank you for that. So one pattern of the slides and the recording, right? So that will be available at the end of this week on hortonworks.com/webinars. I also just uploaded the slide on SlideShare on our Hortonworks account, so you can access it through one of the link I had in the chat box earlier today. So let's get to the first question. I think this is more to Steve earlier on the presentation. Is Swift similar to Amazon S3, Steve?
Okay, I'm answering this. If people can't hear me complain.
We can hear you.
Okay, what was the question again, Swift? Sorry.
Is Swift similar to Amazon S3?
Swift is very similar to Amazon S3. They're both object stores, or known colloquially as blob stores. So you can store data in there, you can read it back. It's not quite a classic file system, so things like renaming is very, very expensive. So what we've done is we make Swift look like a file system as far as Hadoop is concerned, and most of the time Hadoop doesn't notice any difference at all. It's treated like a file system. You have a directory structure. You can copy in files, you can delete them, you can manipulate them from inside Hadoop jobs, and actually inside the Hadoop file system shell that Nirmal was demonstrating. You can read and write files in there. Does that answer the question?
Yeah, and I think the follow-up question is, based on your HDFS reference architecture you did earlier, is the same data set copied to all nodes?
Oh, well, it actually purely depends on the workflow. What we recommend, as we're showing with the demonstration, is that you can start a query by pulling it straight from Swift into the MapReduce engine, into your pig job, into your Hive query. You just say, where's the data come from? And you just give the URL to Swift. And then the first bit of the work does not actually go into HDFS at all. It gets streamed straight from Swift into the MapReduce jobs running on the virtual machines. The output of that, if you don't need to preserve it for any length of time, if it's a one-off, the way the pig query was, you can just give a URL back and it goes straight into Swift again. If you actually want to chain things together, you just say, oh, write it to HDFS, at which point HDFS will decide for itself where in that set of virtual machines it will go. It will do one local and it will do two remote.
Awesome, that's great. Nirmal, this is for you. What other distros are supported by the Rackspace platform currently?
So currently, the only distro we support is Hortonworks.
Great. And then, is this service available right now? Can people start playing around with it at this moment? And if not, then how do they get access to it?
So it's available in early access, which means you got to send us a request, and then we'll add you on to the early access. Once we move on to a limited availability, then you should just be able to, if you have a Rackspace Cloud account, you should be able to access it.
And then another email, sorry, go ahead.
Sorry, for now, just go on to rackspace.com/cloud/big data, and that you'll have information there to actually sign up for the early access. Great.
One question came in, not sure if this is question for Nirmal or Steve. The offering, would it work with sensitive data?
I'll let Nirmal answer that.
So right now we don't encrypt data in flight or data on disk. I think we have a partner, Gazang, who does data encryption, on HDFS. So that's an option you can use if you think you want data to be more secure. But we currently don't have a bundled offering that provides you that.
Right. If there are multiple nodes, and I think this is for Nirmal, if there are multiple nodes performing pattern or predictive analysis, one node can take advantage of the patterns or prediction result from another node?
Sorry, I didn't get that question quite right.
Yeah, I'm trying to kind of reread this question. If you have multiple nodes performing patterns or some predictive analytics that you can do with Hadoop, in the cloud, if one node can take advantage of the patterns or prediction result from another node, can one node communicate to the other node to take advantage of, one data from the other? I guess is what his follow-up was.
Okay, so I'm probably the best one to answer that. And the answer is not in the MapReduce architecture. It's deliberately designed so that each bit of processing runs independently. And the advantage of that is it scales well and you get resilience to failure, because if something crashes, you just rerun that bit. The disadvantage is that because they're not talking to each other, you can only share information at the end of the MapReduce job. So what often people do is they break their work up into lots of little MapReduce jobs and then feed the data back into each other. If you look at the stuff that we're now starting to write on top of Hadoop 2, where the Yarn execution engine lets us write more things, there is work going on to do more complicated operations where there's more communication between them. And the interesting layers there are graph algorithms, where you're sharing it between nodes of a graph, and the stuff we're doing for better, faster Hive workflow called TES, where there's a lot more streaming of results between things going on.
Great. And one other question came in. How do I get my data on-premise into the cloud?
I'll let Nirmal do that one.
Okay. So right now, you can copy data directly into Swift or create a cluster, copy data directly into HDFS. That's going to be okay for maybe hundreds of gigabytes of data, because you're going to be incurred bandwidth charges for incoming. So the SCP is an option. The SCP to HDFS, that's an option. But if you have larger data sets, say ranging in the hundreds of terabytes, so right now there's an option to actually ship your data to us, and we'll just load it into Swift for you all. So that's a more cost-effective solution, so you're not incurred bandwidth charges. Hope that answers the question.
Great. One question came in. Where can I find any training sessions, webinars related to Rackspace and Hortonworks in big data environment use cases? The good news is that Rackspace and us, we're working on a couple of reference architecture and use cases that we will be pushing out via different social channels, blog, and other webinar series. So one of the calls to action is follow us on Twitter. If you register for a webinar, you probably will get more details on any other future Rackspace Hortonworks specific programs we have out there. But do follow us on Twitter. That's where you get the most information on upcoming events and programs. We will have different reference architecture and use cases to kind of educate and bring you through this journey with us. So stay tuned for that. Are we able, Nirmal, this is for you, are we able to host a presented solution? Are we able to host the solution you guys talk about today on-premise private cloud?
So yes, we can. We can do that through private cloud, either on-premise or at Rackspace data centers. And I think we also offer training on using it and setting up private cloud also.
Great. What is the background configuration management solution use? Normal, this is for you.
So we're not using Chef or Puppet or anything. We have an inbuilt configuration system that manages it. So the platform, Lava, does all of that.
Right. Normal, if you can also tell the attendees again how they can get free access for Big Data Platform. I think a couple of people are asking, so if you can just repeat yourself again, that'd be great.
Okay. I think the best way is to contact us through our website. There's a form to fill in.
Great.
And once you fill in the form and provide the details, we should be able to get you hooked on. So just contact us there. Once you fill in the information, someone from Rackspace will get back to you and get you started on the Big Data Platform.
Great. We have time for maybe one more question, so I'm going to ask, in what cases you would not recommend Hadoop in the cloud? Steve, you want to take that just to kind of start off?
Okay. One of the great things about cloud stuff is that it's very agile. You can scale up and scale down based on demand. Okay. I think if you have something that is fixed size, and you want to run it in-house, then actually just saying, I'm going to have a physical cluster, which you're going to keep busy all the time, is kind of a simple solution that works very well. And a lot of the people moving from proof of concept to kind of big applications production do that. So at that point, you are committed to saying, this is what we're going to do. Interesting enough, it's mostly driven not so much by the compute requirements, by the storage capacity. You can predict rate coming in. So that's a decision to go physical is pretty much based on your growth of data and what you want to do with it.
Yeah, also, I mean, if you just want to have a cluster that's available, active 100% of the time, right? You don't want to, or you want to just have it throughout the year for a couple of years, then I think it just matters from a cost perspective. One might be better than the other.
That's great. So with that, I'm going to thank our two speakers for presenting today and the attendees for logging in and hanging out with us for the last hour. We still have some great questions, so I will be working with Steve and Normal and kind of try to answer all of those questions for you and send it to you via email. There were a good handful of questions on the sandbox integration with Rackspace, and we are working on that. So I'm glad to know that there's a lot of interest in this particular thing that we're trying to do with Sandbox. So again, if you follow us on Twitter and kind of log in and try to follow us on with our emails and programs and things like that, you will get a notification once all this is going live. So keep in touch with us, and you will definitely get notified from us via Twitter or an email or some sort of communication. So with that, I'd like to thank everyone for joining, and I will see you guys on the next webinar. Thanks, everyone.
Thanks for dialing in.
Yeah, thank you.